Hello everyone, my name is Isha and our project, as Dr. McMahon stated, was utilizing autonomous drones to identify and mitigate fire hazards near power lines in rural areas. We're in Dr. McMahon's ABY group, and today Nura and I will be presenting. So what is the problem? As many of you would know, California, along with other states like Texas, have been experiencing a huge amount of wildfires over the last few years. A large proportion of these fires have been caused by electrical distribution systems, primarily issues regarding power lines. Over the last 3 years, Texas has experienced nearly 4,000 fires caused mainly because of electrical distribution faults. The Paradise Fire, for example, was caused by a tree falling into the PG&E towers, and it burned over 80,000 structures. So there's a severe need to do something about power lines protection from wildfires. So there are many risk factors we plan on using our drones to look out for. A few examples may include unstable trees or brush that can catch fire immediately if a power line or spark were to fall. Another common cause of fires are arcing conductors, which basically refers to the discharge caused when electricity flows through conductors. In this case, those conductors are the power lines. There are several other risk factors that we will have to consider, including damage or loose components, because these may mishandle the electricity flowing through them and may be a potential fire hazard. So you might be wondering what we're trying to accomplish with this. We try to identify fire risks to power lines, and we're specifically looking for vegetation that is in close proximity to these power lines. So we'll be using an autonomous drone to inspect these power lines for such hazards. And the goal of this project is to mitigate large wildfires by calculating the risk to a high degree of certainty and to use these calculations to alert appropriate authority if a risk is to be found. So while most other projects are focused on the distribution of the poles themselves, our project is focusing more on the surrounding vegetation. And it will use high-resolution images and possibly infrared scans to assess the stability of nearby trees. And we're mainly focusing on vegetation that is in close proximity to the actual power line. This is important because it is really important to make sure that these trees and brushes won't collapse onto a nearby power line during high winds or other unstable weather conditions. Invasive vegetation could create a short circuit or damage the poles, and our drone tries to assess these risks to reduce such chances. So the first key risk factor is the surrounding trees, because these trees can fall over due to high wind and poor stability. We often experience the effects of such disruptions in the form of power outages or network problems caused when the trees fall and take down these power lines. However, when it comes to trees falling, this problem is twofold, because the electricity continues to flow through the line, and this leads to something which we call arching. And this is basically when the high voltage conductors on the power line and the vegetation in the ground, in this case is trees and shrubbery, form a path for electricity to flow through. This leads to the branch or shrubbery lighting a fire and possibly creating the beginnings of a larger wildfire. So now let's talk about why we chose drones to accomplish our goal. So even though these power lines can be inspected manually and have been inspected manually for an extremely long time, it is a really difficult process to do in remote locations and is extremely time consuming. So by using drones, we can inspect more power lines in the same amount of time it takes for this to be inspected manually via cars and other mechanisms, and it's also much more cost efficient. Furthermore, the drones themselves can access remote places that are difficult to reach manually. So there are some current related projects related to this topic. For example, PG&E's wildfire safety programs and initiatives focus on reducing the potential for catastrophic wildfires related to electrical equipment, which would reduce the potential for these fires to spread. The RIDI program enhances the evaluation of SDNGs, overhead electrical power line supplies, and equipment identified within high fire threat district areas. Excel Energy has committed to investing in and using drones, or unmanned aircraft systems, UAS, to inspect its electrical and natural gas systems. The company inspects more than 320,000 miles of electrical and natural gas infrastructure to ensure the safety and reliability of its energy system. EPRI explores using autonomous drones for inspecting power lines and other utility infrastructure as well. This can improve both efficiency and potentially safety by reducing the need for the workers to physically climb onto these power lines and other structures. SCE's wildfire mitigation program seeks to reduce the risk of harming wildlife while repairing utility infrastructure like power lines. And these are just some of the projects that are currently active in an attempt to prevent wildfires. So next, Nero is going to be talking about the hardware of our drone.
Okay, so we have certain parts. So we have this drone kit that comes with a basic drone body, and then we're adding on a visual high resolution camera, which is a GoPro. And we also, in addition, we're gonna have a Raspberry Pi on the drone, so we can run our machine learning model, which we will talk about in a later slide. We also have our Berry GPS IMU GPS, which is a high quality GPS that will ensure that our drone isn't lost. And then we have a receiver which allows us to communicate with our drone when it's flying in the air, with a flight controller, which is what it actually connects to. So we can control, I guess, control the drone. Like it's basically like any controller. A telemetry radio kind of centralizes all the signals, and then we're using lithium ion batteries to help power both the like flight controller and the actual drone itself. So for our drone kit, we actually ended up choosing the Holy Bro X500 V2 ARF kit. So this kit is just a frame body. We plan to attach other parts to the drone. And a quick note on why we chose it. It's because it was one of the most lightweight drone kits we could find, as well as was definitely in our price range, as drone kits can range from almost like $400 to over $1,000, and the drones over $1,000 are just out of budget. So next, we're going to talk about our current set of the drone. So we've done the basic framework of putting together the basic frame body and are currently working on adding the additional parts to the drone. So if you look on the right, you'll see a picture of our basic like drone frame body. And so far we've added on our lithium ion battery. And we're right now working to put together the communication system together, which consists of the GPS or radio telemetry, the receiver, and the flight controller. We're using Q ground control in addition to beta flight control, which are both softwares that help us keep control of our drone at all times. And right now, we are working to connect our drone to the software. So I just want to talk a little bit about of a more underground system, and it's called an ELRS system. So it's basically a radio frequency system that controls remotely piloted aircrafts and ground vehicles. So this is a newer creation that is being used more and more frequently as it offers very fast response times, is open source, making it very customizable, has long distance performance, and is very accessible to the majority. It's also compatible with technology that requires a lot less, not work, but it's easier to work with. So it requires less soldering and so on. And like adding on, we're just using it as it's the most compatible with our previous hardware and software, and it has an open source application, making it very applicable to our project. This is a system that also helps us connect our specific receiver to the drone, to the transmitter. And this is especially where we've had a problem in the past, as the ELRS system, even though it is very useful, it can be a little more difficult to work with, especially when connections and when you're starting off. So now we're going to shift more from our hardware aspect to our software. So our drone, so we're gonna create this drone-based fire hazard detecting system using a Raspberry Pi connected to a camera to monitor basically the power lines and encroaching vegetation. Then we're gonna use a TensorFlow's object detection API, the system that basically identifies objects in real time, while OpenCV processes the images and calculates the distance between the vegetation and power lines. So basically, if the objects are too close, we will have the system flag it as a potential fire hazard, and it will send data to central dashboard for immediate action. So overall, we're kind of using a red flag method, but we do have some other methods. So this kind of goes more into the previous method I was talking about. So what we will be doing is first we'll be selecting relevant data sets, and then we'll group our data into two parts. So trees intersecting power lines and another set that's labeled trees a safe distance from power lines. So in both of these sets, we will be labeling relevant features in the images, such as branches, power line components, and encroaching vegetation. So we're going to train this machine learning model on thousands of pictures of unstable trees, invasive vegetation, and etc. So we'll have 70% training data and 25% testing data, and this model will identify the risks to the power lines. And when the drone discovers a hazard, it will save coordinates, pole number, or other identification so authorities can locate the hazards. Quick note, we do plan to create kind of a software where we can like add these hazard locations to a map where authorities can see. So, like for example, you know those fire risk maps they have for California? We want to model our website software basically on that. So specific things we're gonna be looking for are like dead trees. So if dead trees like decay often at the bottom of the tree, gaps within the branches recrotches because those usually end up growing around the power line, creating like a very high danger. And then trees also that lean towards the sun become a lot more unstable, and we are looking for those especially because those are the ones that are most likely to fall. And then lastly, we're going to be looking for encroaching vegetation. So basically vegetation on the power line or very close to it. Which actually transitions perfectly to our second portion of our software. So we're going to be using distance measurement using an object detection method. So this method identifies the distance between our power line and the brush and trees around it. So firstly, we're going to be collecting a data set of many images, and then we're going to be training our model to detect this brush and trees in the image. Afterwards, we're going to be identifying perspective, and once done, we can calibrate the measurements so this is taken into account. And in the end, we want to be able to identify how far the surrounding brush is from the power line. So once done, we want to be able to classify these distances into two categories, danger or no danger. If it falls under danger, we will put it on that like map we're creating, and local authorities will be notified so they can actually step in. So we actually wanted to we also had this portion of our project where we use generative AI and it has many uses. So as it is difficult to get these specific images of these power lines, we are using generative AI to create images for our models in addition to real life images. This method helps us get many images, but also takes many tries to find images that actually fit our needs. So, for example, if you look on the right, we have two kinds of images. One that's trees not intersecting power lines and trees intersecting with power lines. The one major challenge that we are facing right now is finding images that look realistic enough, but also are look accurate enough for the drone. And I guess for the machine learning model itself, it needs to look not realistic enough, but it needs to be identifiable. So I think that's something we've struggled with in the past. So like transitioning on, we have faced certain roadblocks and challenges. So there were many factors to consider when determining a fire risk. And in the end, we had to narrow down to a few, which were encroaching vegetation and trees around it. And a normal camera may have trouble inspecting areas with congested with trees, meaning that it would just in general, it would be a little harder for the machine learning model to determine if there are risks or not. Also determining tree stability will have to be analyzed by many metrics, not just camera. So that's why we are putting a little less focus on tree stability and more on vegetation encroachment. In addition, bad weather conditions such as high winds or fog leads to low visibility and difficult flight conditions, making it I think less like viable. And lastly, good images are proving hard to gather. So that's why we're branching into generative AI and its uses, but still it's not enough. So we have to explore new solutions to that. Um, so for our future actions, once we finish building our drone, we plan to go test it for stable flight in local parks. Because once we want to put this kind of idea and product out, we want to make sure it has full flight capacity and won't like have failure in certain places. And once we get our drone into flight, we want to collect more pictures for our data sets as that's definitely a new definitely will help us add to our collection. And once we finish building our machine models, we hope to obtain a license to fly drones in a public places so we can fly our drone in state parks and other rural areas where we can actually check the true capacity and like if it actually works. In addition to this, our Holy Bro drone does have autonomous capabilities, which we plan to incorporate for additional convenience in a broader use case. And look, I'm going to talk a little bit about this really quickly. So the way we basically plan to do this is we'll pick one drone line and we'll create a model that basically focuses in on that one line and it has the drone just follow it throughout. So that's how we plan to keep it autonomous. So before we end, I just wanted to acknowledge ASDRP for providing the lab and the means to work on this project, and Dr. McMahon for supporting and providing very valuable insight for this project. So here are literature reviews and sources. Does anyone have any questions on what I said or what Isha said?